Okay, our final example for writing equations of polynomials involves the conjugate root theorem. It's really similar to the problem that we just did, except you'll notice that this conjugate has a square root involved. So if s plus t times square root of u is a root, then the one with the minus sign in between, its complex conjugate, will also be a root. So it's kind of cool. This is going to be the exact same process as the problem we did before, so I'm going to hop straight to the shortcut. Okay, so when we write an equation of a polynomial, remember we're solving for our leading coefficient. So I gave you the zeros. I also gave you a coordinate point that it goes through, and we are trying to solve for that leading coefficient. So y equals a. Here's my first zero, x equals 1. So when we write that as a factor, we change the sign and it becomes x minus 1. And now we have -2 plus and minus the square root of 10. Those are our complex conjugate roots. Well, in order to find out what that turns into as a factor, let's hop straight to our shortcut, which is x squared minus the sum of the conjugates with an x plus the product. Okay, so the sum is going to be -2 plus square root of 10 and -2 minus the square root of 10. Well, the square root of 10's cancel and you're left with -4 there. So this piece right here becomes -4x. Oh, but wait, there's already a negative. So a negative and a negative make that a positive. Bring down your x squared. And now we need the product. So we're going to FOIL -2 plus square root of 10 and -2 minus square root of 10. So -2 times -2 gives me +4. -2 times root 10 gives me positive. -2 times root 10, and then we end up there. Those middle two terms cancel, and 4 minus 10 gives me a -6. So just like that, we ended up with what our lost factor is going to be. And now we can solve for a. We can substitute in that coordinate point for x and y, so -12, and we can solve for that leading coefficient. So x is 2, 2, 2. Perfect. All right, so now we simplify. This gives us 1. This gives us -2, this gives us 6, and so we're left with a is equal to -2. So my final answer is -2 times x minus 1 times x squared plus 4x minus 6. So that shortcut is really helpful whenever you have conjugates, either with a square root or without a square root.